Hello and welcome to North Country Ham. We're going to do another session of study questions for the Amateur Extra Element 4. Going to go through using the Gordon West 2020 to 2024 Extra Class Handbook. And we're moving on to a new chapter from where we left off the last time. And with that, let's get into it. Alrighty guys and gals and everybody watching, I appreciate you stopping in. Hey, if you like anything that I'm doing, showing the DIY projects, anything in ham radio that I'm going over, or even the barbecue, hey, consider hitting that subscribe or liking the videos. I really appreciate the help. So with that, let's get right into this next study session here. Get the camera stuff set up. Bring it right over to show you the overhead on the book here. So we can see here, it's the 2020-2024 Extra Class Element 4 Handbook by Mr. Gordon West. And we've gone through that much of the book so far. We're up to Amps and Power Supplies section now. Page 111 is where we'll start off tonight. We'll go through about 10 or 15 questions, time permitting, and go from there. So let's start right off here. Hopefully everybody can see that pretty good. Let me make sure whether... Looks like it's not bad. Alright, question. Under what circumstances may a dealer sell an external RF power amplifier capable of operation below 144 MHz if it has not been granted FCC certification? A. It was purchased in a used condition from an amateur operator and is sold to another amateur operator for use in that operator station. B. The equipment dealer assembled it from a kit. C. It was imported from a manufacturer in a country that does not require certification of RF power amplifiers. Or D. It was imported from a manufacturer in another country and was certified by that country's government. I'm thinking it's probably either that it was built from a kit or it's from another country's and certified by that country. Amplifiers for frequencies below 144 MHz could be purchased in used condition by an equipment dealer and then sold by that dealer to another amateur operator. This rule prevents the sale and use of amplifiers intended for CB use that are constructed without FCC blessing. Okay, so it's A. Get my little highlighter here so I can remember that later like I always do. So, the correct answer is A. So under what circumstances may a dealer sell an external RF power amplifier capable of operation below 144 MHz if it has not been granted FCC certification? That is A. It was purchased in used condition from an amateur operator and is sold to another amateur operator for use at that operator station. And the book does not want to stay open. Alright, next question. Which of the following best describes one of the standards that must be met by an external RF power amplifier if it is to qualify for a grant of FCC certification? A. It must produce full legal output when driven by not more than 5 watts of mean RF input power. B. It must be capable of external RF switching between its input and output networks. C. It must exhibit a gain of 0 dB or less over its full output range. Or D. It must satisfy the FCC spurious emission standard when operated at the lesser of 1500 watts or its full output power. I think it has to do with it must satisfy the FCC, but in order for an RF amplifier to be granted FCC certification, the amp must meet tight spurious emission standards when it's operating at full power. Let me switch here to finish the answer. Tube amplifiers with large band switching filter networks meet the specs more easily than smaller solid-state amps. This may be why the solid-state amplifiers are still relatively expensive compared to tube amps. The correct answer is D. So we'll switch back over here. So which of the following best describes one of the standards that must be met by external RF power amplifier if it is to qualify for a grant of FCC certification? The correct answer is D. It must satisfy the FCC spurious emission standards when operated at lesser of 1500 watts or its full output power. All right, move on to our next question here. So, which of the following describes an emitter, follower, or common collector amplifier? A two transistor amplifier with the emitter sharing a common bias resistor. B. A differential amplifier with both inputs fed to the emitter of the input transistor. C. OR circuit with only one emitter used for output. D. An amplifier with low impedance output that follows the base input voltage. Not every effective and useful amplifier provides voltage gain. An emitter follower amplifier follows no voltage gain whatsoever, but can provide tremendous power gain, such as when used as the front end of an active antenna. The voltage follower amplifier takes this concept of the emitter follower to the extreme, potentially achieving nearly infinite power gain with no voltage gain. The input circuit of your high impedance oscilloscope is almost certainly a voltage follower. Correct answer is D. So which of the following describes an emitter follower or common collector amplifier? Correct answer is D. An amplifier with low impedance output that follows the base input voltage. All right, moving right along here. Where on the load line of a Class A common emitter amplifier would bias normally be set? And this looks blurry. Trying to clean it up so we can read if you're trying to watch the video too. Alright, that doesn't look too bad on the screen. So, A, approximately halfway between saturation and cutoff. B, where the load line intersects the voltage axis. C, at a point where the bias resistor equals the load resistor. D, at a point where the load line intersects the zero bias current curve. The Class A amplifier offers the greatest linearity but provides only marginal efficiency, usually less than 25%. We normally find the Class A amplifier as a small signal amplifier. It is sometimes used in modulation circuits where perfect linearity is required. The input signal continuously varies the input current over the complete 360 degree of the sine wave signal, with bias normally set approximately halfway between saturation and cutoff. So the correct answer is A, Where on the load line of a Class A common emitter amplifier would bias normally be set? Correct answer A, approximately halfway between the saturation and cutoff. And kind of shows a little bit of a chart here. Various classes of transistorized amplifiers. Got your load line, bias operating point, your cutoff point, and it kind of shows. So, move on to the next ones here. Alright. For what portion, there we go. For what portion of the signal cycle does each active element in a push-pull class AB amplifier conduct? A, more than 180 degrees but less than 360 degrees. B, exactly 180 degrees. C, the entire cycle. D, less than 180 degrees. The Class AB amplifier has some of the properties of both the Class A and the Class B amplifier. It has output for more than 180 degrees of the cycle, but less than 360 degrees of the cycle. Correct answer is A. So, for what portion of the signal cycle does each active element in a push-pull Class AB amplifier conduct? Correct answer A, more than 180 degrees but less than 360 degrees. Moving right along. Which of the following amplifier types reduces even order harmonics? A, push-push, B, push-pull, C, Class C, or D, Class AB. The Class B amplifier may operate a pair of matched tubes in push-pull configuration and operates only over one half of the input cycle. In transistorized Class B amplifiers, the circuit may be called complementary symmetry, where NPN and PNP transistors each conduct over half the cycle. The advantage of the push-pull circuit is the cancellation of even order harmonics, second, fourth, etc. In tube-type Class B amplifiers, it is important that you always change both output tubes together. Never replace one tube and leave the older tube. So the correct answer is B. It kind of shows a little bit of a push-pull amplifier schematic on the page here. So, which of the following amplifier types reduces even order harmonics? Correct answer is B, push-pull. Next one, moving right on here, folks. What is the characteristic of a grounded grid amplifier? A, high power gain. B, high filament voltage. C, low input impedance. Or D, low bandwidth. The grounded grid amplifier remains one of the most popular methods of achieving legal limit HF power output. Yes, vacuum tubes like the 8877 still available, and the power supply may only require B1 plate voltage and a tap off the transformer for AC low filament voltage. Another benefit is 50 ohm low input impedance, closely matching output circuit of your HF transceiver. Answer is C. So what is a characteristic of a grounded grid amplifier? Correct answer is C, low input impedance. Alright, our next question here. How can RF power amplifier be neutralized? A, by increasing the driven power. B, by reducing the driven power. C, by feeding the 180 degree out of phase portion of the output back to the input. D, by feeding an in phase component of the output back to the input. We can keep our power amplified signal clean if the power amplifier is neutralized. Following the instructions in its new manual, chances are you'll be feeding a 180 degree out of phase portion of the output back into the input with neutralizing capacitors chosen to obtain the proper amount of feedback. The correct answer is C. So how can RF power amplifier be neutralized? Correct answer is C, by feeding a 180 degree out of phase portion of the output back to the input. Well then, keep right on moving here onto the next page. Why are odd order rather than even order intermodulation distortion products of concern in linear power amplifiers? A, because they are relatively close in frequency to the desired signal. B, because they are relatively far in frequency from the desired signal. C, because they invert the sidebands causing distortion. Or D, because they maintain sidebands, thus causing multiple duplicate signals. Odd order intermodulation distortion can be a big problem with power amplifiers creating a small amount of in-band spurious emissions close to your operating frequency. Third order IMD will likely elicit ham operators claiming your signal is wide or splattering. So the correct answer is A. Why are odd order rather than even order intermodulation distortion products of concern in linear power amplifiers? Correct answer A, because they are relatively close in frequency to the desired signal. We're just doing all kinds of learning today. More power. What can be done to prevent unwanted oscillations in an RF power amplifier? A, tune the stage for maximum SWR. B, tune both the input and output for maximum power. C, install parasitic suppressors and or neutralize the stage. Or D, use a phase inverter in the output filter. As a new extra soon, you'll likely be operating with a tower and beam tied into power amplifier to boost your transceiver 100 watts output signal. But cautiously work yourself into higher power amplifier operation. Big amps may cause interference to your home electronics, and big amps need to be tuned precisely to minimize parasitic oscillations. When viewed on a spectrum analyzer, parasitic oscillations look like a forest of trees surrounding your transmitter signal. In tube amplifiers, RF chokes in tube plate circuit and small valve bypass and suppressors capacitors in the grid circuit may help reduce unwanted oscillations. With tube amplifiers, step-by-step neutralization procedures are detailed in the owner's manual. If the amplifier is new, you likely won't need to go through the neutralization process until you change out the final amplifier tube. So your correct answer is C. What can be done to prevent unwanted oscillations in an RF power amplifier? Correct answer is C. Install parasitic suppressors and or neutralize the stage. And that one had a lengthy explanation. Move on to our next one here. Which of the following is likely result when a Class C amplifier is used to amplify a single sideband phone signal? A, reduce intermodulation products. B, increase overall intelligibility. C, signal inversion. Or D, signal distortion, excessive bandwidth. The Class AB amplifier will take an input signal and cause a field effect transistor or bipolar transistor to operate near cutoff, but not into cutoff. This will lead to a nearly linear reproduction of the input signal and using a class A, B in common with careful attention to setting the bias just above the point where the signal base current goes into cutoff at 0. Once the transistor is biased beyond cutoff, efficiency continues to climb, but at the cost of distortion, excessive bandwidth. This is why satellite operators using single sideband caution against the use of nonlinear FM only solid-state power amplifiers. The Class C amp for the is fine for data and FM, but for a single sideband voice emission, the Class C amplifier is operating outside of the linear portion of the operation. This causes the single sideband voice signal to sound harsh, distorted, and occupying excessive bandwidth. Never operate your SSB transceiver on voice using a Class C amplifier. The FCC may come knocking. The correct answer is D. So which of the following is likely a result when a Class C amplifier is used to amplify single sideband phone signal? Correct answer D, sound distortion and excessive bandwidth. This is all new to me because I don't have an amplifier. I'm still running just straight 100 watts on an HF and max of 50 watts on VHF right now. So we'll do a couple more questions on this page and finish that page out, and we'll call it a wrap for this particular study session. So, what is a Class D amplifier? A type of amplifier that uses switching technology to achieve high efficiency. B, a low power amplifier that uses a differential amplifier for improved linearity. C, an amplifier that uses drift mode FETs for high efficiency. Or D, a frequency doubling amplifier. A less commonly known amplifier is called Class D. It is made up of two matched transistors driven with enough input power to produce a square wave output. The Class D amplifier employs switching technology to offer high efficiency from its balanced twin devices. So the correct answer is A. It kind of shows here a little bit of a picture of an internal of a amp. And it says the small power amplifier from M Squared Electronics puts out more than a kilowatt. So what is a Class D amplifier? The correct answer is A type of amplifier that uses switching technology to achieve high efficiency. And the last question for the night. Which of the following components form the output of a Class D amplified circuit? A low-pass filter to remove switching signal components. B, a high-pass filter to compensate for low gain at low frequencies. C, a matched load resistor to prevent damage by switching transients. Or D, a temperature compensating load resistor to improve linearity. The Class D amplifier output may be rich in unwanted switching signal components. A low-pass filter allows the square wave to pass on to the next stage while attenuating the unwanted higher frequency components. Answer is A. So which of the following components form the output of a Class D amplified circuit? Correct answer is A low-pass filter to remove switching signal components. All right. Let's switch right on over. All right, well, that does it for tonight's questions. That way we're kind of doing right along. There's always 10 to 15 questions at a time. You know, just it's a lot of information to go through, and retention-wise, and keeping attentiveness on the videos, you know, kind of makes a difference. So we'll wrap it up here for the night. With that, I'll say 7-3. and get on the air.